Progress Check 5 for GCSE Maths Higher. Statistics and Probability. Question number 1. A bag contains 2 black beads, 5 yellow beads and 3 red beads. Natalie takes a bead at random from the bag, records its color and replaces it. She does this 2 more times. Work out the probability that of the 3 beads Natalie takes, exactly 2 are the same color. Write your answer as a fraction in its simplest form, written as A over B. So there are different ways you could work this out. The way that I will do is by writing the different possibilities of having exactly 2 beads of the same color. And this is what I mean. So it could be that Natalie picks a black bead, so we'd want another black bead, and the other one could be yellow or could be red. And we have yellow, yellow, black, or yellow, yellow, red, or red, red, black, red, red, yellow. Black has a probability of 2/10. So times 2/10 again, because there is another black. And yellow, 5/10. 2/10 times 2/10 times 3/10, because that's obviously for red. We then have yellow 5/10 times 5/10 times 2/10. 5/10 times 5/10 times 3/10. Red is 3/10 times 3/10 times 2/10, and 3/10 times 3/10 times yellow, which is 5/10. By multiplying these, you'd have 20 over 1000 here, then 12 over 1000, 50 over 1000, then we have 75 over 1000, we would have 18 over 1000, and finally 45 over 1000. By adding all of these together, we get 220 over 1000. However, we need to consider, when looking at black, black, yellow, we need to be aware that this could be black, yellow, black as well, or yellow, black, black. So our 3 possibilities in total for each and every one of these that we've got already. So this means that this answer that we have here, we need to multiply by 3. So we'll go 220 over 1000 times 3 gives us 660 over 1000. We need to write the answer though in its simplest form. So I can divide both of these by 10 to get 66 over 100. Can divide them by 2 to get 33 over 50, and that's the simplest form. So I'll write this as 33 over 50. Question number 2. In a class of 30 students, all of them have brothers or sisters or both. 19 have a brother, 16 have a sister. Find the probability that a student in the class has a brother and a sister. Write your answer as a fraction in its simplest form. Hint, you could draw a Venn diagram for yourselves to help you interpret the information. So I'm going to draw a Venn diagram. Brothers and sisters. So those who have brothers would go here, and those who have sisters would go in the other circle. So we know that all of them have brothers or sisters. There's going to be no numbers outside of the circles within the box. So I'm going to decide now what numbers to put inside the circles. So there are 19 who have a brother and 16 who have a sister, and that altogether makes 35. But there aren't 35 students in total. So by taking away the 30, that gives me 5, which is the number of students who have both brothers and sisters. So that 5 goes in there. And within the circle for brothers, we'll put 19, take away the 5, because we've counted those 5 already. That gives us 14. And in the other circle, we've got 16. Take away 5, that leaves us with 11. So the question was to write the answer in as a fraction in its simplest form, but it was about finding the probability that a student in the class has a brother and a sister, which is this one, this 5 in here. So that's 5 out of the total number of students is 30. So 5 over 30, which can be simplified. So dividing this by 5 gives us 1/6. In question number 3, we have, again, it's the same question, but we've got to find this. If it's known that a student has a sister, what is the probability that they also have a brother? So we're looking at this circle only, not the whole thing. So the answer will be out of 16, because that's the number of students who have a sister. So if it's known that they have a sister, and 16 of them are known to have a sister, now the number at the top, the numerator, will link to the second part, which is what's the probability that they also have a brother. So out of these who have a sister, which is the 16, 5 of them have a brother as well. So that is 5 out of 16. Can we simplify this further? No, we can't. So we'll write this as 5 over 16. Question number 4. The table shows information about the amount spent by 100 customers in a supermarket. If you completed the table, what would be the cumulative frequency when n is greater than 0 and smaller than or equal to 80? So we have, in the first table on the left, we have the different amounts or range of amounts. So we have up to 20, 17 customers spend up to £20, 23 customers spend between £20 and £40, 36 of them between 40 and 60, and so on. Now next to this table on the right, we have a cumulative frequency table. What this means is that you're looking at a greater range of values. So the first one is identical, the first row, between 0 and 20, so there were 17 of them. That can't change. Whereas when you look at between 0 and 40 now, that the range has expanded. We're not looking at values between 20 and 40, we're looking at 20, between 20 and 40, as well as between 0 and 20. So it includes both of these two. So for that reason, we'll add them together. And that gives us 40. So adding 17 and 23. Now we're looking at the range between 0 and 60. So we'll include all three of them. So we have 40 already for the first two. We add in 36, so that makes it 76. Now we'll include the 14 as well for the next one. So if I add 14 to this, it becomes 90. And if I add the 8, makes it 98, and the 2 makes 100, which is the number of customers that we're given. The question is particularly interested in this one, so let's find it, and that is 90. Question number 5 links to question number 4. What we have to do here is to use the graph to find an estimate for the median amount spent. So we have this cumulative frequency graph which we need to fill in and use to work out the median amount spent. So up to 20 we have 17, so there is vertically we have cumulative frequency, so we'll plot that using this, and the horizontal axis we've got amount spent. So up to 20 amount spent would go to 17, so 17, those 10 in the middle, so 12, 14, 16, so right here or about here, and then up to £40 goes to 40 people. This is easy to plot, this one. And then up to £60 goes to 76, so 76 is right here, and up to £80 goes to 90 people, and up to £100 goes to 98, and 120 goes to 100 people. We'll join the dots together. I can't draw it any better with this pen, but it gives us an idea. So to work out the median amount spent, we're looking at 100 customers, so the median must be at 50 customers. So there we have 50 is in between 40 and 60. So it's going to be an estimate, can't be absolutely accurate. So we're looking at this, which is 42, 44, 46. Question number 6 links to question number 5. So we've got to use the graph to find an estimate for the interquartile range of the amount of money spent. So we found the median. So if we look at the range, we have between 0 and 100, so 100 customers. 50 was halfway through, that gives us the median, and 25 will be the lower quartile, so that would be 25, and then 75 will be the upper quartile. So we'll do exactly the same thing that we did for the median. We'll extend this line to meet the graph. So this is about 30, the lower quartile, which we're going to take away from the upper quartile. So might find it useful to use a ruler in here. So that's about 62. Take away 30, that leaves us with 32. Question number 7 also links to question number 5 and 6. So we've got to use the same graph that we have above to estimate the number of customers who spent more than £90. So we're looking at the horizontal axis where we've got the amount spent in pounds. 90 is in between 80 and 100, so I'll go up this line. You can use a ruler. So we'll go up to where it meets the line, and then we'll go across. So this is about 94. Again, it's an estimate, so anything close to that would be perfectly fine. So that is 94 customers have spent up to, roughly, up to £90. We're looking at customers who spend more than £90. So that is 100 take away 94, which gives us 6. Question number 8. Kim measured the height in centimeters of each tomato plant in her greenhouse. She used the results to draw the box plot shown below. In a box plot, this would be the lowest value. This is the highest value. This is the median. This is the upper quartile. And this is the lower quartile. So the lowest height is 10.5 centimeters. Is this true or false? If we go to the box plot, this is halfway between 10 and 11, so it must be 10.5, so this is true. Question number 9. Kim measured the height in centimeters, so it's the same question. We've got to work out the median height, and the labeling that we just did will help us with that. So going down, we are at 13.123. So 13.3 is the median. This point here, and now we've got to work out the interquartile range. So looking at the upper quartile, that is 13.9. We'll take away the lower quartile, which is 12.7. So this gives us 1.2. That's the interquartile range. Question number 11. A and B are independent events. Given that probability of A is equal to 0.15 and probability of B given A is equal to Y, write the expression for probability of A and B. So if I quickly link these together using a tree diagram, so if you have probability of A and not A, and then we have probability of B given A, probability of not B, same thing over here. So focusing on probability of A, so this would be 0.15, and probability of B given A, so that's this one, given A, what's probability of B, so this is Y. Now we need to work out the probability of A and B, which is exactly this route. So we go across the tree diagram, which means we multiply 0.15 with Y. So a way to write that is 0.15Y. Question number 12. Jordan designs a game for a school fair. He has two 8-sided spinners. The spinners are equally likely to land on each of their sides. One spinner has 3 blue sides, 2 yellow sides, and 3 white sides. The other spinner has 2 blue sides, 2 green sides, and 4 white sides. Calculate the probability that the two spinners will land on the same color. Give your answer as a decimal, do not round. So let's suppose the spinner falls or lands on blue, the first one. Then we need the other one to be blue so that they are in the same color. So this would be, for the first one, 3 out of the 8 possibilities. Then we multiply it by 2 out of the 8. Then we'd look at white, because although there is a yellow side, 2 yellow sides on the first spinner, there are no yellow sides in the second one, so we'll have to leave yellow out. But we have white and white in both of them. So we go white and white. For the first one, that is 3 out of 8. And for the second one, that is 4 out of 8. So multiplying these, we get 6 out of 64 and 12 out of 64. Adding them both together, that gives us 18 out of 64, which is equal to 0.28125. I'll have to take away the fraction. Question number 13 links to question number 12. So it's the same scenario, but we have a different question. Now we've got to calculate the probability that the two spinners will land on different colors. So we looked at the same colors. Now it's about different colors. We know that if the colors are not the same, they're going to be different. So for that reason, we'll work this out by doing 1 take away 18 over 64, or 64 over 64 take away 18 over 64. This is 46 over 64. which as the decimal is 0.71875. We could have also done 1 take away 0.28125. Question number 14. In a class of 40 students, 18 are studying English, 12 are studying maths, and 10 are studying both subjects. What is the probability that a student is studying none of these two subjects, given that they are not studying English? Give your answer as a fraction in its simplest form. We'll use the Venn diagram to help us with this. So we have English, maths. We know that there are 10 who study both of the subjects. We know that there are 18 who study English. That includes the 10 here, so taking away 10, this would be 8. And we have 12 studied maths, so take away 10, that gives us 2. Now we have 10 and 8 and 2, that's 20 students so far, but there are 40 overall, so there must be 20 students who are not studying either maths or English, neither of them. Now we need to find the probability that a student is studying none of these two subjects. So none is the 20. So 20 students study none of the subjects, given that they're not studying English. So how many are not studying English? Let's look at how many are studying English. That is the 18, so this 10 and the 8. And the rest of them, so the 2 and the 20, that's the ones who are not studying English. So this is 20 out of 22. And we can simplify this further by dividing both by 2 to get 10 out of 11. Question number 15. The table and histogram give information about how long in minutes some students took to complete a set of homework. So we have time in minutes between 0 and 10, 10 and 15, 15 and 30, 30 and 50, 50 and 60 and so on. And we've got frequencies for some of these, not for everything. So this is what we're going to be working out. So we'll use the information that we have already. We can see that for a range in minutes between 0 and 10, we have a frequency of 20. So frequency is worked out by multiplying the frequency density by the time. So it is like the two dimensions. Let's say this is width and this is the length, and we're working out the area of the floor, for example, and it begins with the same letter, frequency, floor. So if this area is equal to 20, and we know that this dimension is equal to 10 because it's between 0 and 10, then this means that this here is a 2. So if that's a 2, this is a 1, this is 1.5, and this is 0.5. So this must be 3, 4, 2.5, 3.5. Now this information is going to help us work out the other frequencies. So between 10 and 15, which is this one here, so this is 5, times 3, that gives us 15. And between 15 and 30, that is 15, times 4, that is 60. So what is the frequency for the height being greater than 10 and smaller than or equal to 15, which is this one here? The answer is 15. Question number 16 links to the previous one. So we've got to find the frequency for when h is greater than 15 and smaller than or equal to 30, and that is 60, as you can see from the table that we completed earlier. Questions number 17 and 18, as well as 19, link to the previous ones as well, so the same histogram and the table. So the table and histogram give information about how long in minutes some students took to complete a set of homework. What is the y value of the frequency density for the bar where h is greater than 10 and smaller than or equal to 15? Looking at the histogram, it is this particular one that we're looking at. So going up, and we can see that this is equal to 3. Same question, but now for when h is greater than 15 and smaller than or equal to 30, which is this one here. So going up, this is equal to 4. Question number 19. What's an estimate for the number of students who took 40 minutes or longer to complete their homework? So there are different ways you could work this out. You could complete the histogram. So you'd have to represent the bars in here for these two. So I can do that very quickly. We'd have 62 divided by 20, which gives us 3.1. So it'd go to 3.1 here. And for between 50 and 60, we'd have 23 divided by 10, which gives us 2.3. So 40 and longer, it means we would have to go to this point and add up these two areas that I have highlighted. However, I could do this based on the information I have in the table, because I know that 40 is halfway through 30 and 50. That means I'm going to have to divide 62 by 2 to get 31. Add the 23 as well. So that gives me an estimate of 54. And in the histogram, I have done the same thing. So we've got between 40 and 50, that is 10 times 3.1, that gives me 31, which is the same as this. And we have 10 times 2.3, which is 23. So both together give us 54.